Dear children, today we will learn about drift velocity. So, drift velocity of electrons. So, if you consider a metallic conductor, in a metallic conductor, you know there are large number of free electrons. When no potential difference is applied across the conductor, then the free electrons are in the state of random motion. That means if one electron moves from left to right, another electron will go from right to left. So if one electron moves in the upward direction, other electron will go in the downward direction. So whenever there is no potential difference across the conductor, the average velocity of the electrons will be zero. In the electrostatic condition, means when no potential difference applied across it. So now you see here is a conductor XY. You have applied a potential difference V across the two ends of the conductor. You consider the length of the conductor is L. So now electric field will be developed inside the conductor. So in which direction the electric field will be developed? You know the direction of the electric field is from higher potential to lower potential. You remember this, it is a cell or battery. The line of greater length represents positive terminal and the smaller length represents negative terminal. Positive terminal of the battery means higher potential, negative terminal of the battery means lower potential. So the direction of electric field here is from X to Y, from higher potential to lower potential. But when electric field is developed from higher potential to lower potential, from X to Y, then the electrons inside the conductor will get a force from Y to X, because you know as electron is negatively charged, so the electrons experience force in the opposite direction of electric field. So, but when no potential difference is applied across the conductor, the electrons move at random. When the electrons move at random, their average velocity is 0. So, if U1, U2 up to Un, you consider there are n number of free electrons, are the random velocities of the electrons, then their average velocity U average is equal to U1 plus U2 up to Un is 0, divided by n is equal to 0, that is 0 vector. Their average velocity, that is U1 plus U2 up to Un by n is equal to 0. So now it is when there is no potential difference is applied, means electrons move at random, then their average velocity is 0. But when you apply potential difference, then what happens? You see the electric field is developed inside the conductor from higher potential to lower potential, from X to Y. Then the electrons drift from lower potential to higher potential in the opposite direction of electric field. So, what is drift velocity? Drift velocity, it is the average velocity with which the free electrons inside a conductor move from lower potential to higher potential under the influence of externally applied electric field. So what is drift velocity? Repeating again, it is the average velocity with which the free electrons move from lower to higher potential of a conductor under the influence of externally applied electric field. So let us find what is the average velocity of the free electrons when potential difference is applied, or what is the drift velocity. Here we have to find. So when the electrons, you know the conductor consists of large number of free electrons. So when the electrons will move from lower to higher potential, the electrons will not go straight, because there are a large number of free electrons inside. So while the electrons go from y to x, lower to higher potential, what happens? The electrons get collide with other free electrons as well as the positive metal ions, like this. The electrons move like this. When the electrons move from lower to higher potential, they collide with other free electrons as well as positive metal ions inside the conductor. So you know, in a conductor there are large number of free electrons and also there are large number of positive ions. When the electrons get free from the atom or the molecule, then the remaining part will be a positive ion. So when the electrons move, suppose first collision, the electrons suffer collision. Suppose for first collision the time taken is t1, for second collision the time taken is t2, for nth collision the time taken, let it be tn. What is the average time? It is for, I have considered here first electron. For first electron, the time taken t1 for the first collision, for second collision t2, for third collision t3, and for nth collision it is tn. So what is the average time taken by the first electron in between two consecutive collisions? That is τ1 is equal to d1 plus d2 dot tn by n. So now when what is the electric field developed when potential difference V is applied is equal to V by L. It is the electric field developed inside the conductor. So now what is the force experienced by the electron? A vector force experienced by an electron, A vector, that is minus E vector. What indicates this negative sign? Negative sign, charge of electron you know negative, that's why we have written a negative sign minus E. So this negative sign indicates that the force acting upon the electron is opposite to the direction of electric field. So now the acceleration produced in each electron, that is A vector is equal to A vector by m. M is mass of electron here, m is mass of electron, that equal to minus E vector by m. Equation number 4. So just told τ1 is the average time taken by the first electron in between two consecutive collisions. So what is the final velocity of the first electron? For first electron v1, its initial velocity is u1. You know v is equal to u plus at. So for first electron it is v1 is equal to u1 plus a τ1. Where τ1 is the average time taken by the first electron in between two consecutive collisions. Similarly, V2 means for second electron U2 plus A tau 2. Similarly, for nth electron it is Un plus A tau n. Now you take the average of these velocities. So these are the velocities of the electrons when potential difference is applied. And when potential difference is applied or when external electric field is applied, the average velocity is the drift velocity. So the drift velocity is the average of these velocities. Therefore, drift velocity Vd vector is equal to V1 plus V2 up to Vn by n. So now to write for V1 or Vd vector, for V1 you write U1 plus A tau 1 plus for V2 you can write U2 plus A tau 2 plus dot dot dot. For Vn you can write Un plus A tau n divided by n. So now U1 plus U2 up to Un by n plus A tau 1 plus tau 2 tau n by n. So what is this? It is your zero vector. Zero. It is the average velocity of the electrons when no potential difference is applied. That is zero. Plus A is the acceleration, and it is what? You see, it is the average time taken by the first electron in between two consecutive collisions. For second electron, the average time is tau 2. For nth electron, the average time is tau n, and it is tau 1 plus tau 2 up to tau n by n. It is the average time taken by any electron in between two consecutive collisions. That is called as relaxation time. That is your tau. That equal to A tau. So here we got Vd vector is equal to A tau, where it is the equation number 5, where tau is equal to tau 1 plus tau 2 up to tau n by n. That is your relaxation time. So in place of A you write minus E by m. Therefore Vd vector you got minus E by m into tau. Equation number 6. So you see this negative sign, it is the expression for the drift velocity. This negative sign indicates that the drift velocity is opposite to the direction of electric field. Magnitude E tau by m, but E is equal to V by L. Electric field is equal to potential gradient in magnitude. Therefore, Vd you will get EV tau by ml. It is the expression for drift velocity in terms of potential difference. So here question arises, why it is called as drift velocity? You remember, drift means very very low speed. So when the electrons will move from lower potential to higher potential under the influence of external electric field, as it suffers very large number of collisions, then its speed is very very less. So as the speed of the electron is very very less, so drift velocity is So the velocity is named as drift velocity. So if what is the order of the drift velocity? It is about few millimeter per second. Nearly the order of 10 to the power minus 4 meter per second. So here question arises. Here we are getting electric current due to flow of electrons. So when we switch on or switch off, when here switch on, then instantly the bulb glows. So why instantly the bulb glows though the drift velocity is very less? Because the electrons from the switch will not go from switch to the bulb. What happens? Why the bulb glows? Because due to propagation of electric field. The propagation of electric field inside the conductor is very fast. That is with the speed of light. And due to propagation of the electric field, we are getting electric current instantly. Not it takes some time. So you remember, we are getting electric field inside the conductor, the speed of the electric when potential difference is applied, and that speed of the electron, that speed of the electric field is very high, that is with the speed of light. That's why we are getting current or instantly the bulb glows. So now come to the relationship between electric current and drift velocity. You consider it is a conductor, a potential difference is applied across it. You consider a cross section when the potential difference is applied, the electrons will move from left right to left. Let it is x, it is y, lower potential to higher potential. You consider it is a cross section, it is another cross section. It is x, that is let it be small a, and it is b. The area of cross section you take capital F. So now, as the drift velocity is Vt, if one electron goes from this cross section to this cross section, will take time t. So this distance between A and B cross section, that is Vt into t. So here x is equal to Vt into t. So now, what is the number of electrons passing across the cross section A in time t? The number of electrons passing across cross section small a in time t is equal to number of electrons present within these two cross sections A and B. So the total number of electrons will be small n, number density of free electrons into volume of the conductor between these two cross sections. That is, volume is your area of cross section into distance, A into Vdt. So what is number density? You remember, number density, n is the number density of free electrons. Number density of free electrons, that is number of electrons per unit volume. So now, what is the amount of charge flows across cross section small a? So charge Q is equal to N into E, that is Na Vdt into E. So therefore current I is equal to Q by T, that is Na Vt E, that is equal to near Vt. So it is the relationship between current and drift velocity. I is equal to NEA VD, that is we can say, or it is easy to remember, it is near VD. So now come to mobility. What is mobility? You remember, it is the drift velocity acquired by the free electrons per unit strength of externally applied electric field. If you apply electric field E, then drift velocity developed is Vt. Then mobility is Vt by E. So what is the relationship between current and mobility? We know I is equal to NEA Vt. In place of Vt you can write mu into E. Mu is the mobility. NEA Vt, that is called NEA. In place of Vt you can write mu E. So it is the relationship between current and mobility. So now come to derivation of Ohm's law. Derivation of Ohm's law. Derivation of Ohm's law. We know I is equal to NEA Vt. Correct. So we know it is equation 1 you take, but Vt is equal to EV by ml into tau. So you put this Vt in equation number 1, you will get I is equal to NEA EV by ml into tau. That equal to N E square A tau V by ml. You see, it is NA square tau by ml into V. You see, it is a constant for a conductor. So this constant you take as 1 by R, that equal to V by R. Here you got I is equal to V by R, which is Ohm's law. What is R? R is your ml by Na square tau. It is your resistance of conductor. So you remember, resistance of the conductor R is equal to ml by Na square tau. So now come to resistivity. So from this expression you can say resistance is directly proportional to length and resistance is inversely proportional to area of cross section. The length of the conductor is L and area of cross section is A. So now resistivity rho is equal to Ra by L. So you put ml by Na square tau into A by L, that is M by N square tau. It is your resistivity. Similarly, conductivity sigma is equal to 1 by rho N square tau by M. So from this expression of resistivity or conductivity or resistance, there is tau, and you remember this tau or the relaxation time depends upon temperature. So resistance, resistivity also they depend upon temperature. How they depends upon temperature we'll discuss later. So now come to current density. I is equal to near Vd or I by A, that is NVD, or J is equal to NVD. In place of VD you can write E tau by M, that is N E square tau by M into E. So this is N square tau by M that we have derived, that is sigma. So we can write J is equal to sigma E. In place of N square tau by M, I have written here sigma. And in vector form, that is J vector is equal to sigma E vector. So we have completed here the drift velocity. It is very important topic, so you have to practice this derivation.